Hello. I hope it is audible, right? Okay, then actually there is a power cut. So, anyways, I'm continuing. So, we have discussed about pedestrian level of service. Okay, pedestrian level of service, and we have discussed that how different numericals related to this and that. And with highway capacity manual of 2010 which is published by transportation research board in USA. So mm, from that we have discussed this pedestrian level of service methodology about different terminologies like intersection links and how to mm, uh, calculate the mm, level of service of these facilities that we have discussed. Then we have also discussed about bicycle level of service in the later part, and it is based on HCM 2000. And there are also different types of bicycle facilities like exclusive bicycle path, shared bicycle path, on-street bicycle lane. These things were discussed. Also, bicycle compatibility indexed whether the whether this existing system can accommodate these bicycles or not. These things were also discussed in this lecture 35. So now let's proceed to the question and answers. The first is the figure depicted here is a 3-point Likert scale, 5-point Likert scale, 7-point, or 10-point. So yes, this is a 5-point Likert scale. There are 5 points. So we generally use this Likert scale for questionnaire data or understanding this qualitative response from users. Uh, and this is defined a 5-point Likert scale, and similarly there are also 7-point or 10-point scale can be there. So option A is the correct one. Question 2. In the following equation, what does this BI stands for? Satisfaction rating for physical and user characteristics, importance weight for physical and user characteristic, constant for development of standards for pedestrian facilities, none of the above. Just a minute. So here about discussing the qualitative pedestrian level of service or quality of service, we discussed this walkability index, and where AI and BI are the two terms. AI is the importance weight for physical and user characteristics, and BI is the satisfaction rating for physical and user characteristics. So AI is the importance, that is whether a particular facility is how much important it is, and BI is the satisfaction. We that is how much the satisfaction a person is getting from a particular facility. So here they are asking for BI, that is the satisfaction rating for physical and user characteristics. Option A will be the correct answer here. Next is a numerical. A footpath of width 2 meter in a residential area is to be redesigned and improved by giving importance to perception of pedestrian in terms of satisfaction and their importance on various qualitative footpath attributes. Table 1, this one uh, represent the mean importance, that is A, and satisfaction AI and BI of 10 attributes. There are 10 attributes that are given, like footpath surface, footpath width, like that, comfort, walking environment. So 10 attributes are there, and 200 respondent respond according to these attribute in a scale of 1 to in a Likert scale, and then the mean importance and mean satisfaction table is given here. Now determine the walkability index and corresponding quality of service of the existing footpath as per Indo-HCM 2018. So use this table. Just a second, I am just turning off my video so that this can be on. You can use this formula Wi equal to summation of AI into BI, where I is equal to 1 to 10, as there are 10 attributes. Yes, no, yes, B will be the correct answer. So, so here you have to just use this formula I equal to 1 to 10 AI multiplied by BI. Mm. AI multiplied by BI. So if you, for each case, if you calculate this AI into BI, that is 3.68 into 2, 3.4 into 3, like that, you will get these values 7.36, 10.2, 9.44. And if you add all these values, then it will come as 94.43. That is actually the walkability index. Now you have this table, that is quality of service, that is represented in 5 point from A to E, and there is walkability index score. So this 94 points within this C, so it will be it will be of quality of service C. Sorry, I guess again the screen was not visible. So now I guess the screen is visible. So we have to calculate this walkability index by this formula, and it is coming 94.43, which is corresponding to quality of service C. So the correct answer will be 94.43 and C. That is correct. Next is, which is the best PLOS for judging the performance of a pedestrian facility? Qualitative PLOS, quantitative PLOS, both, or none of this? Yes, both qualitative and quantitative PLOS should be used for judging the performance of the pedestrian facility, because for pedestrian facility there are not only it is some quantitative thing, but there are some subjectiveness, like how comfortable they can walk, or other like this footpath surface, footpath width, these all things are associated. So both this qualitative and quantitative thing is required for developing pedestrian level of service. Option C will be the correct answer. What is this A in this figure? Intersection, link, segment, facility. Yes, correct. These facility. So this is the representation of a of different units of a street. Now intersection is the crossings in the street. So these things are intersections. Then link can span more than one block if intersection is not signalized and where the vehicular traffic don't stop. So link maybe these portions. And then segment is the combination of link score and downstream boundary of the intersection. So this is basically the segment downstream one plus one link. And lastly, a facility is the length weighted average of the segment scores. So this total portion is the facility. This one. So option D will be the correct answer. Again, again, there are some issues with uh, power cut. Because of the power cut. The um, network is not good. Um, Again, sorry for the inconvenience. This one we have discussed that uh, A is the here A is the facility. Then next is which of the following is not a part of roadway characteristics? Built walking environment, flow of pedestrian, physical components, and sidewalk design. Right, B is the correct answer. This flow flow of the pedestrian is not a part of the hello. So B yes. Link is the span more than one block if intersection is not signalized. So link may be this portion or from here to here. But suppose there is a signal here, but if it is not signalized, then total this portion is the link. Like suppose there are uh, two intersections are placed closely, so the signal is here. A vehicle is moving from this to this direction, and there is a signal here, but here there is no signal. So and another intersection is this. So link can span more than one block. So it can span from here to here if the intersection is not signalized. So if here the intersection is not signalized, so it can span from here to here. That not signalized or where the vehicular traffic don't stop. So uh, if the vehicular traffic is not stopping, then it can be from here to here, or if it is stopping, then it can be considered this one can be link, or this one can be link. And this segment is combined link scores and downstream boundary of the intersection. So if you consider this one as a link, then segment is including this downstream one. In this case, if the vehicle is moving to this side, then downstream is this much portion, and this much portion is one link. So total from here to here it is a segment. And the total length weighted average is called, means from first to the end point, it is total facility. Okay. Then in this question, which of the following is not a part of roadway characteristics? uh, Here a roadway and this physical component, sidewalk design, these all are a part of the roadway characteristics. uh, these roadway characteristics is build walking environment, sidewalk, infrastructure, physical component. But this flow of pedestrian is not a roadway characteristics. This is basically a traffic characteristics. Flow of pedestrian or vehicular traffic on the road. So these both these things are required for deriving the perceived LOS score. But here it is saying that which is not a part of the roadway characteristics. So flow of the pedestrian will be the correct answer here. Next is, as per HCM 2010, the PLOS of a link is calculated using PLOS score, that is perceived LOS score using Landis method, and PLOS average space, that is the PLOS calculated using flow characteristics of pedestrian traffic flow. So these are the option. Here it is multiplication, here positive, based, or odds. So which of these is the correct answer? So we have discussed that PLOS, in developing PLOS, roadway characteristics as well as the traffic characteristics are considered. So now for PLOS score, these these mm, roadway characteristics are intersections. These things are considered, and these traffic characteristics like for pedestrian flow or vehicular flow, this PLOS average score is considered. And for a link, it is the votes between PLOS score and PLOS average space. That is, from this roadway and traffic characteristics, there are two pedestrian level of service, and the votes would be the PLOS of the link. So option D will be the correct one here. Next is one link and one adjacent intersection is termed as. So it is, the intersection is basically the downstream intersection. So it is termed as segment. In this one also we have discussed that segment is this one link plus one downstream intersection. So it is basically PLOS of a segment is the link plus intersection. Uh, no, like, if the intersection is like this, if vehicles are moving this one, yeah, this one is the downstream and this one is the upstream. So one next one, this one is the downstream. So direction of the travel is actually this side. So this one plus, okay, in this there might be confusion. This one I actually told the opposite. This is the downstream, like vehicles are flowing this side. So this is the link and this is the downstream intersection. So that is the total segment. Here also, like, direction of the travel is important. So direction of the travel is in this direction, and so this one is the link plus this intersection. This one is total segment, and this is always the downstream intersection. So option C will be the correct answer here. Next is, how is segment PLOS calculated? Link. These are the four options. So we were just in the previous question we are discussing that PLOS is basically this for calculating this segment. It is link PLOS plus intersection PLOS plus roadway crossing facility. So there are three components. One is this. It is talking about segment. So segment means there is link, there is downstream intersection. Now total segment PLOS will be the PLOS of the link plus intersection PLOS and the roadway crossing facility factor FCD. Because there is an intersection, so there will be crossing movement and level of service will be dependent on that. So option C will be the correct answer here. Next one is a numerical. Determine the PLOS of the facility using HCM 2010 methodology. Individual segment PLOS score and average pedestrian space in feet square for the facility is given. This API and IP segment I is given. Use the HCM 2010 formula and calculate the level. Here in this table you can see that there are two components: pedestrian level score and level of service by average pedestrian in feet square per person. So this pedestrian LOS score you need to calculate, that is IP and F, and LOS for average pedestrian space, these values are APF. F, sorry, this is for total facility. I'm directly going to the answer. Here it is still power cut, so I don't know how long the backup will be there. So uh, here we for this step to calculate the level of service, we need this pedestrian level of service score and level of service by average pedestrian space. These two we need to calculate it from this table. And what is the formula for that? That average pedestrian space for facility, that is APF, is summation of Li divided by this Li by API. So Li is the length, and average pedestrian space, that is feet square per pedestrian, is given. These two are given for mm, three segment. It is given the values of length and API. So now we need to calculate APF, and here the denominator is Li by API. So Li by API you need to calculate. So Li, this one, divided by API, this one. And for calculating the pedestrian facility score, that is IPF, it is average pedestrian score, this IP segment I into Li. This value you need to calculate, and for that this I uh, the this one, you IP segment I, and you have to multiply it by Li. So these three values are actually given: length, API, and IP segment I. These three values are given. You need to calculate this one and this one. So this one and this. From there, you have to sum over the number of segment that is given in the question. So it will come, one is this and other one is this one. So if you calculate it, APF will be 41.88. So it is between 40 to 60, and IPF is 3.92. That is between 3 to 4. So if you go from this side and this side, it will come as level of service D. So option D will be the correct answer here. Next is select the false statement with respect to bicycle facilities from the following. Exclusive bicycle off-street paths are physically separated paths from vehicular roads for bicycle traffic. Shared off-street paths are physically separated paths from vehicular roads for bicycle and pedestrian traffic. Third is on-street bicycle lanes are designated bicycle lanes adjacent to roads for uninterrupted flow. And fourth one is interrupted flow bicycle facilities are designed bicycle designated bicycle lanes adjacent to roads operating exclusive of any fixed delays like traffic signal or stop sign. So these are the four options, and you have to find out the false statement. So we discussed about different types of facility. This exclusive bicycle off-street path, it is separated path for vehicular road, physically separated path from the vehicular roads for bicycle traffic. This is exclusive bicycle off-street path. Then there is shared off-street path, that is physically separated path from vehicular roads for bicycle and pedestrian. So it is physically separated, but it is not exclusive. And then bicycle lanes on street, it is designated bicycle lanes adjacent to the roads like this one for uninterrupted flow. And last is interrupted flow bicycle facilities. It is designated bicycle lanes adjacent to roads operating under fixed delays, like they have to obey the traffic signals or stop signs and all. So from this slide, option D is the incorrect one. Is actually interrupted facilities operate under fixed delays, but here it is saying that operating exclusive of any fixed delays. So in interrupted flow bicycle facilities, the delays for the signal and stop, these are considered. But here it is saying that operating exclusive of any fixed delays. So this statement is wrong. These three statements are correct, though. Next one, a northbound, southbound, uninterrupted flow, 3-lane, exclusive bicycle path carries two-way bicycle traffic. Calculate the bicycle level of service of the bicycle path using HCM 2000. The data given are peak hour factor given 0.6, 3 effective lanes, peak hour volume also given 150 vehicle per hour, and the directional split is given 40:60. And the level of service for A to F is given. So ultimately, you need to find out these events per hour, and here it is already saying that it is a 3-lane and two-way bicycle traffic. So 3-lane, two-way bicycle traffic, this one will be used. Hello. Hello. Yes. Uh, the, this one, the directional flow is given here. So it is given as peak hour volume 150, peak hour volume divided by peak hour factor. It is given as point 0.6, and P, that is this directional split. So yeah, for northbound, it will be uh, for northbound it is given as 40 and southbound it is given as 60. So northbound it will be 100 and one for southbound it will be 150 vehicles. Now that is the directional flow. Now we need to calculate FP, that is the number of passing events. So the formula for FP is FP equal to 0.188 Vs. Now if we just directly put these values into this formula 100 and 150, it will be 18.8 and 28.2 for northbound and southbound. Then we need to calculate FM, that is the number of opposing events. So we have calculate the passing event, we have calculating the opposite event, means the vehicles which are coming opposite from the sides of the bicycle. So here we will get these values for northbound and southbound. Now the F, that is the total event, it is we need to calculate this one, that total event. So it is uh, equal to zero point 0.5 FM, that is the number of opposing event, and FP, that is number of passing event. So if you calculate this one with actually the values here, I think this will be 100 and this one will be, sorry, this is right, actually this one, these values again put it here, 300 and 200 and 18.8 and 28.8. So there are 128.8 events for northbound and 128.2 events for the southbound. So in the northbound case, it is the, I think this table is given incorrectly. So northbound, for northbound it is between 140 to 210. So it will be of LOS, and here just a minute, I think it is given as 3 meter wide, 3 lane, two-way. So 3 meter wide, 3 lane, two-way. So we need to see this table, and it will be not E, then it will come for northbound it is 168. So between 140 to 210 it will be C, and for this southbound it will be 128. So it will be B. So southbound it will be B and it will be this C. So ultimately we need to calculate the total event, that is the summation of weighted average of the opposite event 0.5 into FM and FP. So for that, if to calculate FM and FP, there are formulas, and ultimately we will get these two values. See, not Step 4, it is northbound, it is 300. It is 18.8. In lecture note. Hello. Uh, yes, in lecture note, you are uh, e- yes. Uh, okay, okay. In this step, you are saying this step you are saying this one will be 150 and this one will be 100. Okay, okay, right. Okay, I will still just check and I will correct it in the updated PPT. I will correct this the right answer here. Mm, yes, I will still check it once. Then I will mm, post like in the updated PPT. I will update this slide. Okay. So next is which index is used to evaluate the capability of roadways to accommodate both motorist and cyclist. So it is basically bicycle compatibility index. This one, it is to evaluate the capability of roadways to accommodate both motorist and cyclist. Next is how to calculate peak hour value from ADT, that is average annual daily traffic, peak hour factor, that is K, and D, directional split. ADT into K into D, right? So peak hour peak hour value is this ADT, the average annual daily traffic, K, that is peak hour factor, which is generally between zero point 0.7 to 0.15, and D is the directional split. So the first one will be the correct answer. Next is a 4-lane arterial serves as a commuting bicycle corridor. The curb lane width is measured from the center of the lane line to the gutter pan seam and is 3.5 meter. The AADT on this segment is to 20,000 vehicles per day. The posted speed limit is 65 km per hour and the 85th percentile speed was not available. There is no on-street parking and the development along the roadside primarily consists of residences. Consider no adjustment factor, AF equal to 0, K equal to zero point 0.1, D is 0.55. Compute the BCI and BLOS. Also, the following BCI is given by the following formula. This you can use and this table you can use. So we need to use this formula, this one for bicycle composite index 3.67 minus 0.966 BL. That is, BL is the presence of bicycle lane or paved shoulder. So in this case, there is no on street parking, and and this presence of bicycle lane or paved shoulder is not there, so BL equal to 0. Then BLW, that is bicycle lane width. So if BL is 0, then it is also 0. Then curved lane width, it is given 3.5 in this question. Then for curved length volume and other lane volume in same direction, so these two CLV and OLV we need to calculate, and for calculating that we have the in the question it is given the AADT 20,000, N is 2 lanes in one direction, and K is 0.10. Now if we consider these default values 0.55 and 0.10, and this speed is 65 kilometer given as posted speed limit. So 85th percentile speed should be posted speed limit plus 15. So in by doing that it will come as 80. So this value will be 80. Now this parking, there is no parking in this case, so PKG is 0. Area type is residential area, so it is 1. And finally adjustment factor is 0. It is given here. Yes, yes, it is actually by default we are taking these values, like uh, if the posted speed limit is available then it's okay, but if there is the posted speed limit is not present, in that case we generally use posted speed limit plus 15 kilometer per hour. uh, uh, so that's why in this case we have added, but if the given the 85th percentile speed is given already, so that time we don't need to add this 15 kilometer per hour. So it is 85th percentile speed, and as it is not given, so we add 15 kilometer, because uh, generally in a road the posted speed limit people should obey, but in general it has been found that people are driving at a higher speed than the posted speed limit. So 85th percentile speed is generally considered 15%, 15 kilometer per hour more than the speed that is posted in that particular road. So it will be 80. And uh, now we need to calculate this CLV and OLV, and for calculating CLV and OLV we need pick our factor. So it will be ADT K into D. So ADT 20,000, K default value of K is 0.10 and D value is 0.55. So it will come as 1100. Now CLV is PHP divided by n. N is not, there are two lanes in one direction, so that will be n. And this OLV is PHP minus CLV. This PHP 1100 minus 550, so 550. Now we know every value in this equation, so we can just put these values here like 3.55, 550, 80 or 0, and it will come as 4.743. Now if we see this table, BLOS BCI range and compatibility level, so it will fall under this very low category. So the correct option will be E and 4.743, 4.743 and E. This option B will be the correct answer here. So that's all for this session. Sorry for the inconvenience caused. Please check later the video, and if you have any doubt, then you can post it in the discussion forum, or you can also ask in the next live session. I hope these numericals are clear. So mainly these are based on different formulas, and this numerical I will check once and will update the correct PPT in the drive. So that's all for this session. And in the last session, if you have any doubt, like this is the last session, we last week we discussed this one. So if you have any doubt, then you can ask about this also. We have we are discussing about different NMT characteristics, and we have just started their pedestrian level of service. There we discussed about independent t-test and how to calculate it. Then we discussed about different flow parameters. Then different macroscopic, microscopic, these models were discussed. Okay, this one. So here it is saying that consider a hypothetical data. This data is given for density and speed, and determine the parameters of the flow model using Green-Childs relationship E equal to A plus BK. So this model is given, and you need to find the uh, value of this A and B. Then only you can determine the parameter of the models, that is A and B. Now for finding A, the formula is this one, and for B this one. So formula of finding A is dependent on B. So first you need to find B, parameter B. Now parameter B formula is xi minus x bar, and you know that k is given, u is given. So speed is considered as y and k is considered as x. So this is generally considered, the speed is considered as y and it is a function of the x. So xi minus x bar, first term is xi minus x bar. So you need to calculate this xi. Xi is the average. Sorry, x bar is the average. So if you just average this fourth term, then it will come as 97. Now xi minus x bar is 168 minus 97, so it will come as 71. Similarly, for this term 135 minus 97, it will come 38. Like that, all xi minus x bar we need to calculate. Similarly, for yi minus y bar we need to calculate, and it is the multiplication of these two terms. So we need to multiply these two and we will get this value and sum it up, then this is our numerator, and the denominator is xi minus x bar square. So xi minus x bar we know, we just have to square it and add it, then that will be our denominator. Then you can b and a easily you can get. Then it is one numerical, that speed density relationship is given as this one, and we need to find the relationship between qp and kp. So this is the main formula, q equal to kv or qp equal to vp into kp. It is similar to like in traffic engineering case, we also generally q equal to kv we read. Similar to this case also, it is q equal to kv, and from there vp equal to qp by kp. Now the relationship is given between vp and kp and asking for qp and kp. So this one is given and asking for qp and kp. Now can we represent vp as in terms of qp and kp? So we if we consider this one, then there is a relationship exists between this vp, qp and kp. So we can always represent this vp in terms of qp and kp, as there is some relationship exists between these three. So it will be qp by kp equal to vp. So we just have to put qp by kp in place of vp, and this one is rest is same this side, right hand side. So ultimately it will come as qp equal to 60 kp. It is like qp by kp equal to 60 minus 10 kp. So this kp will go upside, so qp equal to 60 kp minus 10 kp square. So it is the relationship between qp and kp. So 60 kp square minus kp, that will be the answer. Similar to this question, there is another question. There is it is asking between qp and vp, not kp. In this case, it is vp. So we know that uh, we derived last one that k equal to q by v. Now in this case, vp equal to q by k. So in place of vp, q by k. So this one, oh, we derived this one qp and kp relation. Now there is also a relation exists between q, k and v. So kp equal to q by v. If we just put this value in this equation now, that q qp equal to 60 kp 10 kp square. So if we just uh, if we use this one, then we will get qp equal to 60. In place of kp we use vp minus vp square by 10. So just we are just subsequently this qp and for this qp and vp we are just putting this kp equal to qp by vp. So this one, and there this one is another math which is determining the critical gap, where length of gap is given, frequency is given. Means every time how many people accepting a particular gap, that is given, this 0, 10, 20, 30, like that. So from this is the frequency that 0 to 1 second gap, 10 people are accepting, then 1 to 2 second, 20 people are accepting. These frequencies are given, and uh, to find the critical gap, we need to it is a intersection between number of accepted gaps and number of rejected gaps. So these accepted gaps are increasing and the rejected gaps are decreasing. So suppose a person has to cross a particular road. So if vehicle are continuously flowing, like there is a only 2 second gap or 1 second gap between every vehicle, then it might be difficult for him or her to cross that road. So he may not cross that road. In that is said, that is they are rejecting that gap. But if the gap is very much high, like say 6 second, 8 second, then they will definitely try to cross a particular road, provided the road is not a the width of the road is not very high. So therefore, if we calculate that number of accepted gaps, so you can see that 0 to 1 second, only very 10 people are crossing. They have, means they have accepted that gap. Then 20 to 2 to 3 seconds, 60 people are crossing in that. Then 3 to 4, 100 people, then 154 to 20. It is basically 0 plus 10. This means frequency you have to, it is cumulative one, that for every second there are frequencies are given for 0 to 1, 1 to 2, 2 to 3, and the cumulative one, that total how many number of people accepted that gap, that will be done by cumulative, uh, by adding the cumulative numbers. So total it will 0 to n 30, like that. Again, for this particular case, 66 people are uh, rejecting that gap. So it is a number of rejected gaps that is greater than t second, that is 66. So again, for less than that one, that you need to find the cumulative one, like 66 plus 54, it will come as 120. Then 120 plus 40, it will come as 160. 160 plus 30, it will 190. Like that, it will come as 220. So 220 people are rejecting a gap of 0 second, but all the people are accepting a gap of 6 second. It can be interpreted like that, that every people are rejecting a small gap, but every people are accepting a large gap, maybe 5 to 6 seconds. So now you need to plot these all are length of gaps in t second. So it is 1 second, 2 second, 3 second. You may take the middle value of that for plotting purpose, and the number of accepted gaps are this one, that continuously increasing, that number of accepted gaps, and number of rejected gaps at the downward trend, that 1 second is rejected by maximum people, accepted by very few maybe, but for 6 second may be accepted by many more people, but rejected by less people. So where these two intersect, that will be the critical gap. So this one we need is our point of interest. So it is coming as 5.7 second. If we plot it in the graph, so the correct answer will be 5.7 second. Next we were also, this one is just the effective width we have to calculate. So there is a facility given 3.5 meter and shy distance is zero point 0.6. Like if someone is walking, then they might not get very close to the curb or very close to this side. So if the pedestrian are walking in a place which they are comfortable, so it is basically the total width maybe No, it may be between this curb and this pedestrian. That this in this case, this is the shy distance that people may not go like if there is curb or there is some object here, then people may not uh, go just beside that. So they will maintain certain gaps, maybe 1.5 feet here. So they will maintain certain gap from that object or from that particular thing. So that's why for maybe psychological. Yes. Yes, yes, it is the curb between street and this footpath, and this side maybe some building is there or fencing is there. So this distance, they will not just exactly go by this line, they will maintain certain distance from there. In both sides they will maintain certain distance. So uh, mm, mm, even if we give a total length of 3.5 meter, maybe available width, maybe total width, that is the total facility width is 3.5 meter we are giving, but effectively people are walking only in this portion. Don't consider this one. Or in this case, if there is some trees present, so people are going in that route. But it is in this question, it is not that complicated. So it is saying that just there are side distance in both the side for 0.6 meter. So both the side, this side is 0.6 meter and this side is 0.6 meter. So this is the effective width. So even if we give 3.5 meter as total width, but people will walk by consider by maintaining a particular distance from the edge of the footpath. So it is given as 0.6 meter here. This one is given as zero point 0.6. This one also given as zero point 0.6. So actual effective width will be 3.5 minus both sides there is zero point 0.6 deficient, so it will be around 2.3. This, this one is saying that a 5-meter wide footpath in an commercial area is barricaded with guardrail on both sides. The existing peak flow rate is 1200 pedestrian per 15 minutes. What will be the pedestrian level of service? These two tables are given. So you need to calculate this pedestrian level of service from this table. And in what unit this table is given? Pedestrian per minute per meter. And you have pedestrians per 15-minute value. And you also have this 5-meter value. And it is also saying that commercial area is barricaded with guardrail on both sides. So people will not go just beside the guardrail, they will maintain certain distance from that guardrail. And for commercial area, if it is a guardrail, what is the shy distance that will you will get from this table? So if there is some obstacle, then people maintain certain distance, that is shy distance. And if it is guardrail in both side, then the value is zero point 0.4 to zero point 0.6, between zero point 0.4 to zero point 0.6. So we can take in between one value, let's say zero point 0.5. So we are taking high distance value as zero point 0.5 and it is both sides, so multiplied by 2, total width is 5 meter, so it will come as 4 meter effective width. And you know the pedestrian flow, that is 1200% per 15 minute, so 80% per minute. And you need this unit, pedestrian per minute per meter. So you just divide this pedestrian flow rate, you have to consider, that is 20 pedestrian per minute, and it will come as in LOSC. Then calculate the PLOS of pedestrian crossing at both major and minor street of a signalized intersection operating with 100-second cycle length and no pedestrian signals. Major street says green time is given, crosswalk length is given, minor street also the values are given, and this PLOS one is the table. So pedestrian delay for major street will be 0.5 C minus G of the minor divided by total cycle length. So this is the formula. Total cycle length is given 100. It is given 100 and G mean is given as 33. So it will come 22.44. So it will between 20 to 30. So it is LOSC. And for the minor street, this G is the major one. So G major is given 48 second. So 100 minus 48 by 100. So it is 13.52 second. So it will be PLOS B. This table. This one will be provided. Yes, this will be provided. This wherever this kind of table will be needed, then there it will be provided, and it is available in the highway capacity manual 2000, maybe even the later versions of it like 2010 also the same table is there. And this one we have, you can search in the like uh, last day I have searched like HCM if you what the HCM 2010 PDF, that one is available. I guess this PDF is available. Maybe some I think 2016 is the latest one that uh, sometimes may not be available, but this 2010 I guess uh, mm, you can just search here and this PDF will open. Mm, I think there will be, yes. Uh, I'm not sure. Just no, like last few lectures, I think something else. Last is transport and sustainability. Their last few lectures maybe is different, but this level of service and these things will go on for maybe one or two lectures. I need to check that, but it will like this level of service calculations. There are many formulas and all that. And yes, if someone some planning authority planning persons are want to develop a bicycle facility in an existing city, then they can use these formulas. They will take questionnaire surveys, they will conduct questionnaire surveys, and they will collect people's response that how they are satisfied with existing facilities or what facility can be given. After that they will analyze these data, like we have analyzed this different in different context, like these data will be analyzed, and then they will try to provide try to determine what will be the width of that bicycle lane, or what facilities should be given to encourage the people more and more, or mainly the level of service. It, it is very much actually context specific, like how much is the proportion of the bicycle, like if a like first we need to check that how much bicycle is passing at that location, whether a dedicated bicycle lane will be used by them or not. Then we can uh, see that whether that will like whether we can take it from that existing carriageway or different, like we are discussing that different types of facilities, bicycle facilities may be there here, like this one, that there may be different types of bicycle facility that exclusively for bicycle. If there are the bicycle volume is very high, then we can provide this exclusive lane. Or if maybe in case of Kolkata, in some cases there are previously there are no bicycle lanes or like that, but recently they are trying to develop these bicycle lanes just uh, beside the main carriageway, and maybe separating it with barricade, or these parkings will be somewhat make them these bicycle safer, like the vehicles are going here are in a greater speed, so so that these bicyclists are protected, then they are the parking may be placed in between. This kind of thing may be there before, and the width may be fixed based on this level of service criteria, that how many people, one from one perspective, that how many people will in the maybe 10 years or 20 years time period, how many people will use that facility, and also there is how comfortable they want to be, like if the width is very low and the many people want to go by bicycle in that road, then they might feel it uncomfortable, and eventually they will discourage about using this bicycle. So to encourage them, the weight must be sufficient. This kind of, also this level of service is one of the, that's why this level of service is one of the important aspect of this before developing any bicycle facility or maybe footpath facility in a particular place. So this kind of, yes, there are from in place of like places where there are maybe office areas. There are many offices in and around around a particular metro station. There maybe these type of schemes can be developed. Like people will rent one bicycle rental scheme. Like people will rent a bicycle from a particular metro station, and they will there might be some satellite parking station, or they may park at their destination point of a particular office area. Then people will more prone to use that metro facility or some other public transportation, so that will eventually decongest our streets. So in older cities it is very important to provide these kind of facilities to encourage people using public transport, like uh, the in older cities roads are already congested, so there are very limited space. So if more and more people are encouraged to use this non-motorized transport, bicycle or walking facility, if good walking facility can be given, and then people might want to walk a maybe up to 500 meter or 1 kilometer they want to walk. So this kind of facility can be developed so that uh, like uh, people can use it, and eventually they will try to use public transportation. So, in some cases, these analyses are also conducted for before developing a particular metro station. Like in Kolkata, there are some metro stations are planning for develop. So the metro construction is going on, but government is also looking that how the facility can be enhanced, like whether bicycle facility can be provided, or this people can rent one bicycle from the metro station and go particular place, or how to encourage people to use different bicycle, or even walking for a very less distance. And uh, for that people has to be satisfied with that facility. So safety, security, or these like there should be enough space for seating, maybe that if anyone wants to sit, or this kind of facility also can be developed. And this will come from that questionnaire survey, that what people want or what facility will encourage them to use that footpath or pedestrian facility. So these kind of surveys and this kind of analysis can be done in this planning context. Okay, so that's all for this session, and we will again meet on next Monday maybe. Yes. Yes. L- Lecture 3. Okay. Okay. Yes, so week 7 it is. This one. In this slide. This one. This one. This one. Okay. I think there is some lag in this one. Right. Okay. Just let me check the numerical ones. Determine the mm, PLOS score and corresponding PLOS of the roadway using HCM. So in that case, we can take in general that shouldn't be like in mm, in practical it shouldn't be case, but if there are issues like both the condition is satisfied, then we can take any of the formulas. So for both this one and as well as for the this uh, down one, both can be taken. So in that case, in numerical question, it will, I guess, not be given like that. But if in practical, similar kind of uh, problem can is faced that both the condition is satisfied, then maybe any of the formula can be taken. Yes. Okay. Thank you. So let's close the session. Thank you very much for joining.